Hi, this is Mrs. Youd, and today I'm going to teach you about how to find the cube root. Make sure that you have watched the other videos I assigned first about the basics of exponents, roots, and finding square roots before continuing. You should be taking notes in your spiral notebook while watching this video so that you can use your notes when you're doing your assignments. First, some vocab. When you multiply a number by itself 3 times, you cube the number. For example, 4 times 4 times 4 equals 4 to the power of 3, which is also called 4 cubed. And 4 to the power of 3 is 64. To undo this, you need to take the cube root of the number. For example, the cube root of 64 is the same as the cube root of 4 to the power of 3. Now, this cube root and this third cancel out, and we are left with just 4. And lastly, a perfect cube is a number that can be written as the cube of an integer. For example, the cubed root of 8 is 2, because 2 times 2 times 2 equals 8. And the cubed root of 27 is 3, because 3 times 3 times 3 equals 27. Let's look at some examples. For example 1, we need to find the cube root. For letter A, we have the cubed root of negative 27. Now, how I like to do it is break it down using the tree structure. 27 is 9 times 3, and 9 is 3 times 3. You'll notice that we have 3 3's here, and we have a cubed root. So that means that this is the same as the cubed root of negative 3 times negative 3 times negative 3. And I put the negatives in because there's a negative here. So since there's 3 negative 3's in there, we know our answer is negative 3. For letter B, I have the cubed root of the fraction 1 over 64. We can break this down and say that this is the same as the cubed root of 1 over the cubed root of 64. Now, let's take a look at those individually. The cubed root of 1, if we try to think of 3 numbers that multiply to 1, that of course equals 1. So the cubed root of 1 is 1. Now let's do the cubed root of 64. If we break down 64, we can do 8 times 8, and 4 times 2 is what 8 breaks down into on both of those, and 4 breaks down into 2 and 2. So what you notice is that we have a group of 2's here, there's 3 of them, and a group of 3 2's here. So that means that there are 2 sets of 2's that are going to be coming out, and then the answer would be 4. So we have a final answer of 1 over 4. Now if we look at this again and see if this makes sense. Okay, look back at the original one. Does 1/4 times 1/4 times 1/4 equal 1 over 64? And yes, it does. So we got it right. On letter C, we're doing the cubed root of negative 64. Now we just learned on letter B that the answer has to be 4 because but in this case it's going to be negative 4 because negative 4 times negative 4 times negative 4 will be negative 64. So the answer is negative 4. On letter D, I have the cubed root of negative 125 over 216. So I'm going to take each one of these separately. This is the cubed root of 125 over the cubed root of 216. I know that there's a negative in here, and that is going to be part of the answer as well. So I know that I'm going to have a negative answer here. We just need to figure out what the cubed root of 125 and the cubed root of 216 is. So let's take each of these separately. 125 is 5 times 25. And 25 breaks down into 5 and 5. So there we have a group of 3 5's here. So I know that the top answer is 5. Now let's take a look at the 216. 216 is an even number, so I can break it down by taking out some 2's. So I'm going to take out a 2, and that gives me 108 left over. Let's take out another 2, and we get 54. Take out another 2, and we get 27. So now 27 is 9 times 3, and 9 is 3 times 3. Okay, so let's see what we have here. We have a group of 3 2's, and we have a group of 3 3's. So that means that the cubed root of 216 is 2 times 3. You only take out one of the 2's and one of the 3's, which is 6. So then the final answer is -5/6. In example 2, we need to evaluate the expression. For letter A, we have 2 times the third root of -216 minus 3. Now, from the previous example in example 1, we learned that 216 was 6 times 6 times 6. So since there's a negative here, we need to make this -6 times -6 times -6. So that means that we have 2 from this piece here multiplied by -6 minus 3, which gives us -12 minus 3, which is -15. So the answer is -15. For letter B, we have the third root of 125 all raised to the power of 3. Now remember that when you have a third root and a power that's the same, they cancel each other out. So that leaves us just with 125 plus 21, which is 146. Letter C, we have the same sort of thing. We have the third root and a power of 3. So those cancel each other out, and we're left with 10 minus 12, which is -2. For letter D, I have 2 times the third root of 512 plus 10. So let's do a little bit of work in breaking down 512. 512, I can take out a 4, and that leaves me with 128. And I can take out another 4, and that leaves me with 32. And I can take out another 4, and that leaves me with 8. And 8 is 4 times 2, and 2 times 2. So here we have a group of 3 4's, and we have a group of 3 2's. So that means that the third root of 512 is 4 times 2, which is 8. So let's use that in our problem here. So we have 2 multiplied by 8 plus 10. 2 times 8 is 16. And 16 plus 10 is 26. So the answer is 26. In example 3, we need to evaluate the algebraic expression. So in each of these problems, we are given an algebraic expression, and we're given what that variable equals. In this case, x equals 192. So what we need to do is take the 192 and substitute it in for the x on both of these parts. And so there I've rewritten the algebraic expression, but instead of x, I wrote 192. So now we need to simplify this. 192 divided by 4 is 48. And 192 divided by 3 is 64. So this is 48 plus the third root of 64. 64 breaks down into 8 times 8, and 8 is 3 2's on both of these. So I have one group of 2's, another group of 2's, so that means this is equal to 48 plus 2 times 2, or 48 plus 4, which is 52. So the answer for letter A is 52. For letter B, we're going to substitute 64 in, so that's the third root of 8 times 64 plus 64. Instead of multiplying 8 times 64, I'm going to just break down 64 into 8 and 8, because I know that I need a group of 3. And notice that now I have 3 8's coming out here. So that means this is the same as 8 plus 64, which is 72. So the answer for letter B is 72. For letter C, I need to substitute in -3. So I have 2 multiplied by -3. I put it in parentheses because it's a negative, minus the third root of 9 times negative 3. Simplifying this, I get negative 6 minus the third root of negative 27. Negative 27 is negative 3 times negative 3 times negative 3. So that means this is negative 6 minus a negative 3, which is negative 6 plus 3, which is negative 3. So the answer for letter C is negative 3. For our last example, we have a real-life application. The volume of a cube is 1,000 cubic inches. A, what is the edge length of the cube? And B, what is the surface area of the cube? I always like to work from a picture, so I'm going to draw a cube. We can draw a cube by starting with a square, and then if you draw little diagonal lines coming off of the square and connect them, you have a nice picture of a cube. So we're dealing with volume. We're told that the volume of the cube is 1,000 cubic inches. So if you remember, volume is the side length of the cube multiplied by itself. And since it's a cube, we know that all the side lengths are the same length. So we can say that these are length x, which means x times x times x is equal to 1,000 cubic inches, or x to the power of 3 is equal to 1,000 cubic inches. Now, in order to undo this cube, we need to take the cube root. So we're going to take the cube root on both sides. And what that does is it cancels out the cube and the cube root on the left, and we're left with just plain old x here. And then now we need to find out what the cube root of 1,000 is. So if we think about 1,000 and break it down, 1,000 breaks down into 10 times 100, and 100 is 10 times 10. That means that the cube root of 1,000 is 10. So now we have the edge length of the cube. The edge length of the cube is 10 inches. Okay, so now let's find the surface area of the cube. We look back up at our picture here. The surface area is what all the surfaces add up to. Now, one of the surfaces of the cube is a square. And if you think about what a cube looks like, there are 6 squares in a cube. The area of a square is the length of one side times itself. In this case, we have 10 and 10. So that means that we have 6 squares, and each square is 10 squared, or 10 times 10. So that would be 6 multiplied by 100, which would be 600. So the surface area of the cube is 600 inches squared. All right, this concludes today's lesson about finding cube roots.